In this video, I'll walk through how to try out the new Dream 7B diffusion reasoning model, which is claimed to be the most powerful open diffusion large language model. The vast majority of other large language models are autoregressive. Diffusion models are frequently used for image generation models such as Stable Diffusion. Over on the Stable Diffusion Wikipedia page, there's this nice image that shows how Stable Diffusion goes through a number of steps to denoise the image, and increasing the step count can increase the quality of the image. Let's take a look at Dream 7B to see how this would work with a text-based diffusion large language model. Let's take a look at the configuration items that are available here in the interface. The max new token specifies the maximum size of the response the model can provide, and I'm going to increase this up to 256 tokens. We'll start with the diffusion steps set at 128. I found that increasing the temperature up to 0.4 helps improve the response, and we'll change the algorithm to origin. I'll ask the model to provide the top 5 possible explanations for the Fermi paradox. You'll notice right away that diffusion large language models work much differently than a normal autoregressive model. An autoregressive model predicts the next word in the sequence, so the output is generated in a standard word-by-word sequential output. A diffusion model goes through a series of steps to denoise, and you see the output emerge non-sequentially. The number of diffusion steps determines the amount of time it takes to process, as well as the quality of the output. For example, if I reduce the number of diffusion steps way down to 8 steps and use the same prompt, the model will very quickly produce a result. However, as you can see, it's mostly meaningless since we had the steps turned way down too low. Let's try this again one more time with the steps turned up to 256. This will be slower, but we should see a better result than the first time we ran this query with 128 steps. The Dream 7B paper mentions that the Dream model excels in tasks requiring planning, and one of the examples mentioned in the paper is Sudoku. So let's give a Sudoku question a try. I'm going to follow the same Sudoku prompt from the paper, but I'll change this to a different puzzle than what was listed in the paper. I'll turn the max new tokens down to 128, and I found that the entropy algorithm worked best for solving these type of Sudoku puzzles. And I'll turn the diffusion steps all the way up to 512. This is going to take about 50 seconds, so I'll speed up the video here. And the generated results does look correct. Next, I'll cover how to get the Dream 7B model up and running in a container with Podman. In this example, I'm using an NVIDIA GPU, and I've already installed the NVIDIA driver and the NVIDIA container toolkit so that Podman containers can access the GPU. I have a Git repository with a container file, so I'll start by cloning this repository. Let's take a look at the container file. As you can see, this is based on the CentOS Stream 9 container image. It installs some Python 3.12 packages and the Git package. It clones the Dream GitHub repository and uses pip to install some Python packages. The default Gradio application wouldn't run on my system with 24 gigs of video RAM unless I modified the app.py to use bfloat16. So there's a sed command to make this change. I'm not using the Gradio share link functionality, so there's another sed command to disable that. And finally, since this will be running within a container, I set the Gradio server name variable to 0.0.0.0 to enable communication outside of the container. Next, I'll build the container with the podman build command and tag it with the Dream 7B name. I've already run this previously, so it uses the cached layers and completes very quickly. Next, I'll run the container with the podman run command. When the container starts, it will download the model files, which will take some time depending on your internet connection speed. I'll go ahead and speed up the video here. Once the model has been downloaded, you can open a web browser and browse to localhost on port 7860 to access the Gradio web interface, where you can start trying out the Dream 7B model. Well, thanks for watching, and have a great rest of your day.